started, I want to sketch. I want to see where they fall. Yesterday we sketched all the pieces on one. In the beginning, I want you to put all the parts on one, like we did together in class. Keep it there so that you can see where it's going. I want to look at the area to the left, and we're going to incorporate that into this. This just had us look for z-scores, but I want to incorporate your area to the left of this. Now, when you do this, you go back to your old formula. You're going to come out with your z-score. It should be where you think it's supposed to be. If you lay all these pieces out, you should find them where they are. And I think we did the first two, and you had to do the last two. So were you okay with this? And then find your area? Your area is the cumulative area to the left. So it kind of gives you like a ranking. Where did this fall? And for SAT scores, that's important as well. Where are you ranked? Because that's what the college administrators, that's what they'll be looking for. Like, not necessarily your score, but where are you ranked in your class? If it's like an Ivy League school, they're real strict. They'll only take like the top 5, top 10%. So they want to know where was that cutoff. They want to see where are you in relation to your class. So telling them what your z-score is or your score doesn't mean anything to them. Telling them you're ranked 91st in your class, that's what they want to see. You're ranked 44th in your class, so they're probably not going to like that score. So these are really used in the world now. They're used these in colleges. SATs and ACTs run like this. ACTs probably not as normally distributed as these, because usually not everybody takes an ACT. Usually the better students take the ACTs, from what I understand. So you get a little bit of both. Again, do the same thing. Make sure you give me a sketch. Make sure I see your parts. Do one sketch for all of them like we did yesterday. That's absolutely even better. Lay out your standard deviation across it. Put your mean in the middle and pull your mean out. And just add your 5.3 and subtract your 5.3 all the way down. Easiest way to do it, give me one sketch. And then just add your 5.3 and then subtract your 5.3 and go all the way down. And you kind of get a good feel for where they are. It also helps you when your z-score, and I know you're going to say to me, oh, I know it's positive and negative, but I can't tell you how many kids will always subtract the larger minus the smaller. Because since you're little, you always subtract the bigger minus the smaller. And you'll never give me a negative. But if you see it actually on the negative side, that should tell you my z-score has to be negative. And every year kids say, oh, that's so obvious. Oh, not so when you're doing these. Okay? Then we had a couple of, remember we flipped these to probabilities. The probability is the area under your curve. So the probabilities are combining with your z-scores, with your standard normal curves, and we're using the probability as the area. So if I want the probability that z is less than 1.45, I'm going to look to the left and get my area. If I want it greater than, I'm going to subtract my area from 1. Okay? And if I expect it to be more than 50%, yeah, it better be. If I expect it to be less than, yep, it'll be less than. It's a good gauge to keep that in mind. Stop me if you have any questions. To the right, you're going to do the 1 minus. Could you use your calculator? Absolutely. Could you extrapolate this if you didn't round it? If you rounded it to 2.18, then you're going to get 1 minus 0.9854. If you extrapolated it, because it's exactly in the middle, you're going to find the difference, divide it by 2, and either add it to the first one or subtract it from the second one. All right. The greater than, that one works. The in-between, everybody okay with the in-between? The in-between, make sure you subtract your areas, not your z-scores. Find your areas. The in-between is the best one on the calculator, because you got your lower level and your upper level. You don't have to use any of the 999s. And the or says add. Looking back to our probability, we had ors that were mutually exclusive, and these two sections are mutually exclusive. They do not overlap. So in an or, we add. So therefore, we're going to add those two pieces together. Or just take one here. Since this is symmetric, whatever this area is, and multiply it by 2. Easiest way to do it, right?
What if you had something that was too heavy and you do the one that is?
Yes, you do. But what happens is this is symmetric. So here's your curve. So your -1 is equal distance from the 0 as 1 is, right? So this area over here is the same as this area over here, because these two areas are exactly the same. And aren't they both 50% on both halves, right? So if I find this area, that should be the same as this, because my curve is symmetric, because these two numbers are the exact same. They're the same distance away from 0. So in this case, all I have to do is find this one. If I look this one up, I have to take its area and subtract it from 1, which will give me this. So I'm going to get that regardless, and you can absolutely do that. If you see the symmetry, it makes life a little bit easier. So you guys good with this? You're good for a quiz tomorrow? Okay. Most of the quiz